Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
The first method that we're going to review for converting fractions to decimals is the standard algorithm for long division. We're going to use the same value in each method. I chose the value of 5/8. When we are converting the fraction 5/8 to a decimal and using the standard algorithm, we use a symbol that looks like this, and we place our numbers in certain positions. So the numerator goes on the right and the denominator goes on the left. So this is 5 divided by 8. And I added the decimal point and zeros so that we have some placeholders. When we do long division, we say 8 goes into 5 0 times. Then we move our decimal point up. It just goes straight up and stays in the same place. Now we look at 8 goes into 56 times. 6 times 8 is what we're used to, but this is really 6/10 times 8. So that is 4 8/10. Then we subtract, and we have 2/10 remaining. 8 goes into 20 hundredths, 2 hundredths times. So 2 hundredths times 8 is 16 hundredths. We subtract, and our difference is 4 hundredths. 8 goes into 40 thousandths 5 times. 5 thousandths times 8 equals 40 thousandths. We subtract, and we get 0. Once you get 0 here, you have completed the standard algorithm for long division. So the fraction 5/8 is equal to 625 thousandths. Okay, our second method is using powers of 10. So we're going to start with the same fraction, 5/8, and we're going to use powers of 10 to convert it to a decimal. I'm going to start out by using the prime factorization of 8. And to find the prime factorization of 8, we need factor trees. So 8 is the same thing as 2 times 4. Notice I've circled the 2. That's because the 2 is a prime number, and that part or that branch of the factor tree is over. It cannot go on anymore. The 4, on the other hand, can. So 2 times 2 is 4. And again, those are prime numbers, so I've circled them. My factor tree is complete. So the prime factorization of 8 would be 2 times 2 times 2. 8 equals 2 cubed. I'm going to rewrite my fraction 5/8 using my 2 cubed instead of 8. And to get to a power of 10 on my denominator, I'm going to have to multiply by 5 cubed. Well, if I multiply the denominator by 5 cubed, I have to do the same thing to the numerator. And 5 cubed is 125. So you can see we've got the 5 cubed has turned into 125, and then my 2 cubed times 5 cubed has turned into 10 cubed. Then I just multiply. What is 5 times 125? It's 625. And I've expanded out my 10 cubed to be 1,000. So this fraction is read as 625 thousandths, which is very similar. In fact, it's the same way that we read it as a decimal. So that actually tells you your answer. And it is 0.625 or 625 thousandths. The third method is another long division algorithm. So the first method was a very standard algorithm that most people know, and this is a little different. So we still have 5/8. And I'm going to do some basic long division over here on the other side. Remember, our numerator is on the right side and our denominator is on the left side. And 8 goes into 5 0 times. 0 times 8 equals 0. Then we subtract and we get 5. So this gives me a remainder of 5. So I'm going to rewrite this 5 in my fraction, my numerator, using basically everything that's outside of this symbol to organize it a little differently. So 5/8 is going to be equal to 0 times 8 plus 5 divided by 8. So I've got the 0 that's above the 5 on my long division, and then my remainder is just added on. Now what we can do, because of some properties, we can separate this fraction at the plus sign. So I'm going to do that. Now I have two fractions. I have 0 times 8 divided by 8 plus 5/8. Now this 8 divided by 8 right here will cancel out. So I'm left with 5/8 equals 0 plus 5/8. And this seems a little repetitive at this point, but when we get into more difficult numbers and examples, you won't have a 0 here, so it will make a little more sense. Okay. At this point, 5/8 should be considered a benchmark fraction, meaning you should have that value memorized. Benchmark fractions are going to be your halves, thirds, fourths, fifths, sixths, maybe not your sevenths, eighths. We'll talk about ninths a little bit later, and of course tenths. So you should have those memorized without needing to calculate any further. So at this point, since it's a benchmark fraction, you should know that 5/8 equals 625 thousandths. So that means that this is 0 plus 625 thousandths, or just 625 thousandths. The fourth method is the long division algorithm with powers of 10. So we're going to work with our 5/8 again, and this time we are going to multiply it by a power of 10, and I just chose to the third. You can really choose any power you want. It kind of fixes itself. When you do this, you want to remember that 10/3 is equal to 1,000. Okay. I'm going to rewrite this as 5 times 1,000 divided by 8 times 1 over 10 cubed. Now 1 over 10 cubed is a unit fraction. Any fraction that has a 1 in the numerator is considered a unit fraction. That's an important step here. You want to pull that unit fraction out with a power of 10 as the denominator. Well, now that we have 5 times 1,000, we're going to go ahead and multiply that out, and it's going to become 5,000 over 8. And then we're going to do our long division just a little bit like we did before. So 5 goes into 56 times, and that 6 represents 600. 600 times 8 is 4,800. Then we subtract and have 200 remaining. 8 goes into 20 2 times. That 2 represents a 20, so 20 times 8 is 160. Then we subtract, and we have 40 remaining. 8 goes into 40 5 times. 5 times 8 is 40. We subtract, and we have 0 remaining. And so I'm going to go ahead and put my remainder 0. We're going to rewrite the 5,000, that's our numerator, using the 8 times 625 plus our remainder of 0. And we're going to keep our unit fraction here. Now, just like we did on another method, we can split this fraction into 2. So you have 625 times 8 divided by 8 plus 0 divided by 8. The 8's in the numerator and denominator are going to become a 1, so they go away. and this leaves us with 625 plus 0 times 1 over 10 cubed. And then this is multiplication, so we're just going to multiply this out to get 625 divided by 10 cubed. Remember, 10 cubed is the same thing as 1,000. And then this is read as 625 thousandths, which tells us our decimal. The fifth method is using inequalities. So we start with 5/8. 5/8 is not a number greater than 1. So the whole number part, or the ones place, on this decimal is 0. And then we add the remaining pieces, which would be 5/8 to it. So like I just said, the 0 is ones place, and the 5/8 represents, or begins to represent, the tenths place. We use the 5/8 fraction in this setup right here, where you have m over 10 is less than the 5/8, which is less than m plus 1 over 10. And then we multiply by 10 to get rid of the denominators that are 10. And remember, we're working to find the tenths place, and we're working with tens, so this is all going together. Well, 5 times 10 is 50. So we get m is less than 50/8, which is less than m plus 1. And then we break down 50/8, just like we did at the beginning here, where I'm going to break it into 48/8 plus 2/8. 48/8 is the same thing as 6. And 2/8 is the same thing as 1/4. So this 6 tells me what goes in the tenths place. So now we have 5/8 is equal to 0.6 plus 1/40th. Now why is it not 1/4? Remember, up here we multiplied by 10. So essentially we're having to divide by 10 to kind of undo that. So we get 1/40th. And this 1/40th begins to represent what goes in the hundredths place. And we're going to repeat this for the hundredths place. Notice that I now have denominators of 100, meaning that I am now going to multiply by 100. 1 times 100 is 100, so we have 100 over 40. And I'm going to separate that into 80 divided by 40 plus 20 divided by 40. 80 divided by 40 is 2, and 20/40ths is 1/2. So this 2 tells me my hundredths place. So now I know that 5/8 equals 0.62 plus 1/200. Remember, we have a 1/2 here, but since we multiplied by 100, we're going to have to go ahead and divide it out, or divide by 100 here. So this 1/200 shows me the thousandths place. We do the same exact steps. This time we work with thousandths. We multiply by 1,000. 1,000 divided by 200. Well, 1,000 divided by 200 is just 5. There's nothing to add on there. So that 5 tells me the thousandths place. And I get 625 thousandths for my answer. Okay, this method is not converting fractions to decimals. It's actually converting decimals to fractions, but it's a certain type of decimal. So we're going to look at repeating decimals. If I have the repeating decimal of 0.444 and it is equal to W, you can set it equal to any variable. The W is not really important as far as which letter I chose. Then I'm just going to rearrange it so that we know W equals 0.44 repeating. We can do that with equations. I'm going to go ahead and multiply this by 10 so that I can have something in the ones place. I end up getting 10W equals 4.444 repeating. Now notice that my 10, when I multiplied by 10, I also multiplied the W by 10. It's very important you get every piece of that equation. Then I'm going to take the first one that we started out with, I'm going to subtract it from this 10W. And 10 W's minus one of them equals 9W. And 4.44 repeating minus the 0.44 repeating leaves us with just 4. Then we solve this equation for W by dividing by 9. We get W equals 4/9. And remember, from up here where we started, W also equals 0.444 repeating.
Only shooting stars.